Welcome to part 2 of sniffing, reverse engineering, and writing ESP32 Bluetooth low energy code. In this episode, we're actually going to sniff some traffic and reverse engineer it. In part 1, we installed the software necessary to do this and discuss the hardware. And in part 3, we'll actually take what we reverse engineered and write some code on the ESP32 to leverage it. Now we're going to reverse engineer this device. It's called a Lumin Plus Smart Light. There's a Bluetooth application that's available for it, and the device looks like this. You can actually pick this up at 5 and Below for $4.99. So let's go over to the computer and start sniffing. So before we get started sniffing, we need to get some base knowledge down here. I'll include these links below. This is the Bluetooth.com website, which is a fantastic resource for understanding Bluetooth. A couple concepts that we need to understand is, in a typical web situation, you have, a server, a web server, and you have a client, and the client connects to the web server. Well, there's a similar concept here, except the servers actually broadcast. They make themselves known, and this allows devices then to connect to them. This is called GAT. There's also a concept called GAP that we'll talk about. But what the key here is that everything is driven by a UUID. A UUID is a universal identifier. Some people have called them GUIDs. And what it does is allows you to define both. So you have the server, and it's going to have a unique identifier. The services on that server, they each have a unique identifier. There can be 0 to many. And then every service has characteristics that are identified by a UUID, and there can be 0 to many of those. So if you kind of want to think about it, you might think of maybe the server as an application, let's say, and then the services as classes, and then the characteristics kind of as methods within that class. That's probably an easy way to think about it, but Bluetooth Low Energy is much more complicated than that. There's lots of options to it. You can do mesh networks, beacons, there's all sorts of things that Bluetooth Low Energy does that Bluetooth Classic didn't do. It's all about Bluetooth Low Energy is all about low energy, as you would expect. It's all about Internet of Things, things that can run on a watch battery kind of stuff. So it's designed around that concept. So what you're going to find is, I mentioned GAT, and then which is basically the methods, the services are available, and then GAP, which is this discovery method where the actual Bluetooth server broadcasts that it's available, and you can even query it from the client to see what's available. So I'll share these links with you. I highly recommend going to this website. There's a discussion about service discovery. There's a talk about the base IDs. Really, all this comes into play when you think about Bluetooth as being able to provide services to you without concern of which server it is. A quick example, obvious example, let's say that you have a Fitbit or some kind of watch on that can tell you your current heart rate. Well, instead of connecting just to that watch, what you can actually do is listen to the advertised Bluetooth servers, and instead of focusing on the server itself, you can actually focus on the service that you're looking for. And there are a standard set of services that you can find. This is called service discovery. And let's say that you want, there's a lot of them listed here. But let's say that you want to find something that has, heartbeat information. Well, that could be on the watch. It also could be, let's say, a device connected next to your hospital bed. So it's the service that becomes more important than the server. And there are ways for you to discover what services are available and how to use those services. So here's another page I'll share with you. We're going to need one more application. that we didn't cover in part 1, and that is this NRF Connect, or a similar tool. It's free, it's available for iOS, and it's also available for Android. And this is going to allow us to resend some traffic as we start doing the reverse engineering. It's actually a really nice tool. It'll show you all the Bluetooth broadcasts that are going on in the area. It'll help us find the lamp that we're about to reverse engineer. So anyway, this is a tool you need, or something similar to it. There's a number of Bluetooth scanners, if you will, available, but this is a really good one. And then last but not least, if you're looking to buy the actual lamp, I'll include the link to where you can get it. It's $5 below, it's $5. There you see it. You can probably find it locally. Alright, so what I want to show you is the NRF application on my iPad here. So when we bring up the NRF application, well, mine's already starting to scan. You can see that it's found it's a beacon, my Apple TV, all sorts of stuff. But the light is actually not on yet. What we're going to do is, while it's scanning, we're going to turn the light on and look to see when this device advertises and what its name is. So I just turned it on, and okay, right here at the bottom it says Trions, and it has a number. That is this device. And we should be able to prove that by turning it off, stop scanning, scan again, and let's see if it goes away. It hasn't gone away yet. Let's close the app. It's probably just remembering it. Bring it back up again and start scanning. Okay, so it's already scanning and we don't have the device. I turn on the device and it finds it. There it is right there. So that is the actual device that represents this lamp. Now if we pull up the Happy Lighting application that comes with it, I want you to be able to see both of these. You can actually go through and change the color. I just pressed green. I don't know why this app is like this. It's just poorly written, I guess. But the colors are actually overlapping. There's blue, yellow, purple. Looks like I can change the colors this way, and there's an on-off button up here. Off, on, which it has to be a soft off-on. It's still working, actually. Okay, so with that, what we're going to do is actually send some of these commands to the device while we're using Wireshark, so that we can sniff the traffic and determine the communications between the application and the device. Then, once we think we've figured it out, we'll be able to go back to the NRF application, connect to the device, and try to send it some commands. So what we're seeing here are the advertisements from the lamp, and also we're seeing some writes, like here's a write, this is read write, that's notify. So these are different types of abilities that this Bluetooth low energy device has. So let's go back, let's look at some Wireshark data and see if we can figure out how to reverse engineer the communication. You might be asking yourself, why can't you just use the NRF? Well, we're not actually seeing the traffic between the smartphone application and the device that contains data. All we're seeing right now in the NRF is what is being advertised. That advertisement is probably not enough to figure out the format of the data that's being sent to the device. Now, if this was maybe a higher end device, maybe a heart monitor produced by Apple or something like that, they would probably have listed their service and characteristics on the Bluetooth.com website. So we wouldn't have to do this reverse engineering. The reverse engineering comes into play when those interfaces, those services and characteristics aren't properly documented, or you know, basically properly documented. So, all right, with that, we're going to pull up Wireshark now. All right, so we've got Wireshark up and running. We've got the NF52480 dongle in place, and we got the sniffer here. Everything else is kind of turned off. My iPad's Bluetooth, and the actual device is turned off. Let's start this, and now we start seeing traffic. These are things broadcasting. In fact, you can kind of see advertising that they exist in my home. So what I'm going to do now is I'm going to turn on the Lumin Plus light, and it should start broadcasting. And when it does, we should be able to see its name right here in the advertised list. And now I want to just filter on that traffic from the device. I'm now going to turn on the Bluetooth on my iPad, which you can see. Let's go and run the application, and we see that. And now what we want to do is send a series of commands that we can pretty much remember and repeat if we want, so that we can properly do the reverse engineering. So I'm just going to follow. I'm going to press red, then I'm going to press green, then I'm going to press the blue, and then I'm going to do an off, and then I'm going to do an on. And that's it. So we're going to go ahead and stop. All right, so now what we want to do is look at our traffic. So let's go through here from the bottom up. It's always a good idea to save this traffic too. Okay, here's a command. Here it is. ATT, it's like a GAT, it's a command. And if we take a look, we can see that there was a service UID and a UUID and a value. So let's pull up Notepad. So the first thing we did was send a red, then we sent a green, then we sent a blue, and then an off and an on. So what I'm going to do is I'm actually going to filter. Let's see. I want to filter this data, apply a filter. Let's see if I can do this. Okay, I did on all the right commands. So let's see what we have here. The last one would have been an on, an off, blue, green, red. And these must have been while the app was like connecting, you know, when the app started. Okay, so let's look at these real quick. If this is the on command, we can see that it is service FFD5. So let's go to this. It is service FFD5, characteristic FFD9. Oops, I'm doing the wrong one. Sorry. This is for on. That would have been the last one. And the value was CC2333. So let's look at the next one. Look at that, CC2433. And it looks like it's exactly the same. So that's the command, that's the service and characteristic and value that we need to send to it, most likely, to get it to turn on and off. And we'll try this in just a few moments. Let's take a look at the colors. Blue would have been this one. Let's pull back up our notepad. So it's the same service, it's even the same characteristic, but the value is different. Interesting. Okay. I don't know what that. Let's copy the value, and paste it here. And then let's look at what green does. If we go back, okay, I'm betting that it's just the value that's changing. Let's take a look at this one. Let's copy the value, paste it, and now let's do red, which this should be the red command. Okay, so it looks the same, except for that value should be different. That's the red command. Let's copy the value and paste it in here. So what are we seeing? Okay, they all start with 56. They all end with 01F0AA. And what is this? Okay, this is most likely the RGB colors. We've got red, we've got green, RG, so 0 red, green, no blue, and then this weird blue, which I'm guessing is a little green and a little blue. Not very blue, but okay. So two things. Let's just go ahead and save off our data here. So let's save it to a file. Lumin Sniff. Okay, and then let's save this data. We'll call that commands, Lumin commands. Okay. Now what we need to do is we need to use that NRF Connect application, and let's try to send some of these commands back to the device and see if it works. So these are the commands, and what I've done is I've pulled up the NRF Connect application on my iPad. And if we scan, we should find, okay, yep, that's our application. That's Triones. That's the name of the Lumin Plus device. Let's connect to it. So now that we've connected to it, looking at our information that we collected through reverse engineering, we found that this is the service, this is the characteristic. Let me fix that. That's the service, that's the characteristic, and these are the values that we've sent. So in theory, to prove that we can actually talk to the device, using the NRF, we can go and find, let's see, there's our service. It's listed as FFD5. And under that is an unknown characteristic with a UUID of FFD9. So if we press this, NRF allows us to send a byte array, a Boolean. So we're actually going to try, let's try to turn it off. The off command should be CC2433. CC2433. We know it's a command, it's not a request, and we're going to write it. And the light went off. Fantastic. So let's turn it back on again. And that's going to be CC2333 as a command, and it's back on. Okay, so let's see if we've got the colors right. We know we can, if we send this command, the 567B00, you know, on and on, ending in AA, that it should go red. So let's just repeat the exact same command. So we're going to send 56 7B 000001 F0 AA, and it went red. So it's, yeah, I think we've nailed it. Basically, if I want to send it, let's say instead of this bad blue, which was 7B7B, let's try that. So let's send it RGB, so we'll send it as an FF. So let's go. So it would be 56, and then the R color, oh, hold on, 56, the R color will be 00. The green color will make 00. RGB, the blue color will be FF. Then we're going to send a 01 F0 and it should be like a dark blue. Purple. Well, it's pretty blue though. All right, so fantastic. So now we have figured out the commands. Really what we figured out is the service, the characteristics, and the values, and how the values are packed. So now, in part 3 of this video, we can actually, using an ESP32, we can actually go and write some embedded code to make the ESP32, which supports Bluetooth, classic and low energy, and control this device. Put down in the comments below any ideas you have of what you would like to see it do. The idea that I came up with was maybe having it use a heat map and show the weather outside, temperature outside based upon the colors, but I'm open to any kinds of suggestions. That's it. So with that, I think we've made some significant headway. All right, see you in part 3.